Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! If I split this shape into two sets of 6 blocks, when we're asked to shade in 3/6, for each one of those, or each set of blocks, I'm going to shade in 3 of the 6. So that's 3 for the first set, and this is 3 for the second set. And that's our answer. Now you might notice that 3/6 is the same as a half, because we can divide on 1 by 3, and so all I need to do is shade in a half. Or you might convert 3/6 into 6/12, and there's 12 squares altogether, so it's 6 of the 12 squares. There's lots of ways of doing this question. If we tried to draw a quadrilateral with a pair of parallel sides, and then it's a quadrilateral, so join them up, it's got 4 sides, then the shape we draw will always be a trapezium. So our answer is that it is a trapezium. Now you might think that a rectangle and square does have one pair of parallel sides, but it actually has 2 pairs of parallel sides. The definition of a trapezium is it has just one pair of parallel sides, and any quadrilateral that has one pair of parallel sides is a trapezium. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10, including the back ones. So we need to first of all understand what a cube number is. So a cube number is the answer to when you get 3 integers or whole numbers and we multiply them by themselves 3 times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64, and it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. When collecting terms, you've got to make sure you're collecting like terms. So what I'm going to do is I'm going to write this question out, but I'm going to use a different colour for all the things that are like terms. So we've got the 14x, we've got the 8x squared, we've got the 8x, and we've got the minus 5x squared. So the like terms are the x terms, so 14x plus, I should say 8x, plus 8x, and the x squared terms are like terms, so we've got 8x squared, take away 5x squared. So we can do 14x plus 8x, so 14 lots of x plus 8 lots of x is going to be 22 lots of x. And we can do 8x squared minus 5x squared, 8 lots of x squared, take away 5 lots of x squared is going to be 3 lots of x squared. Now typically in our answer we'll always put the x squareds first, so it becomes 3x squared plus 22x. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. And to work this out, we just need to type in 0.3 on the calculator and then press a button that mostly on most calculators looks like this, and it will just square it for us. If you can't find that button, all you need to do is do 0.3 times 0.3, and that will give you the same answer of 0.09. So we're told the sequence starts at 20, so our first term will be 20, and we're told that the rule is add 5, so we're going to add 5 to that, and that will be 25 for our second term, add 5 again, and that will be 30 for our third term. So I'm going to just copy that number down again, just make it a bit bigger so we can see what we're doing. Okay, we're asked to work that out, round it to 3 significant figures. That means 3 numbers from the left hand side. So starting here, 1, 2, 3. Now the first number has to be not a 0. So if it was a decimal, we would start counting as soon as it wasn't a 0. After that 4, then we're going to put a line down. Now all the numbers are going to turn into 0 on the right hand side. So these numbers here will all turn to zeros. But before they do, we need to look at this number. Now this number is a decider number. If it is 5 or more, then it will push this number up by 1. If it's less than 5, then nothing will happen. Because it's less than 5, all the numbers to the right will turn into zeros. And with decimals, if they're zeros, we don't need to write them. So the answer would be 30.4. We're going to start off by writing the numbers that the dots are at. So we've got minus 12 and we've got minus 5. And x is anywhere between those. Now, it's obviously going to be greater than minus 12. And it's going to be less than minus 5. But it can equal minus 12. And the reason for that is it's a filled in dot. But it can't equal minus 5 because that is a hollow dot. I'm going to start by just copying out the question. Now the word solve means find out what x is, and the first thing we do when we see solve is draw lines to the left and right of our equal sign so we can solve it. So there's 2 things stopping us from having x on its own, this over 5 and this take away 10. Now that take away 10 isn't in the fraction, and normally I would say to get rid of the fractions first, but because that take away 10 is just sitting there on its own, we need to get rid of that first. So what I'm going to do is the opposite of take away 10 to both sides. So we're going to add 10 to both sides. That will leave the x over 5 on the left hand side, and 0 plus 10 is 10. So we want to get rid of this over 5, but what does over 5 mean? Well, it means divided by 5. So the opposite, the inverse of divided by 5 is times 5. So I'm going to do that to both sides. So we're left with x on the left hand side, 10 times 5 is 50. So x equals 50. So when simplifying ratio, it's very similar to simplifying fractions, but instead of the same thing having to do the same thing to the top and bottom, you have to do the same thing to the left and right. So I'm going to start here by dividing both sides by 100. So I notice they both have 2 zeros at the end. So that'll give me 10 here and 34 here. Now, these are both even numbers, so a nice easy next one to do is dividing by 2. And we get, was it 17? And 5 and 17, well, they're both prime numbers, and so there's nothing we can cancel them by, so it's going to be our answer, 5 to 17. First thing I'm going to do to answer this question is I'm just going to quickly draw out the shape again, just so I can show the calculations a bit easier. Okay, the first thing I'm going to do on the diagram is convert all of these lengths to centimetres. So we've got 4,200, 1,200, 2,400 and 1,800. And next I'm going to convert them into what the scale says they're going to be in our diagram. So a scale of 1 to 600 means 600 in real life, and this diagram is showing the real life situation, is 1 on our diagram. So I've converted them all into centimetres, and now I need to work out how many centimetres there are going to be on our diagram. So I'm going to start with the 4,200, and all you need to do is divide it by 600, and I get the answer of 7. So it's going to be 7 centimetres on our diagram. 1,200 divided by 600, it's going to be 2. So that's going to be 2 centimetres on our diagram. 2,400 is obviously going to be 4 centimetres. And 1,800, divide that by the 600, it's obviously going to be 3. So it's going to be 3 centimetres. So now we know what it's going to be on our diagram. We draw it. So we're going to do 7 across. So 1, 2, 3, 4, 5, 6, 7 across there. I'm going to do 2 down. So 1, 2, 4 across. 1, 2, 3, 4. I'm going to do the left hand one first, I think. So we're going to do 3 down here. And then we just kind of join it up with what's left over. And that's our diagram. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it would be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. The lowest point on this graph is here, and that's at point 6, and the highest point is here at point 20. And we're looking for percentage change or percentage increase. And the formula is change over original times 100. So the change between the 6 and the 20 is 14. The original, the starting point, was the 6 and times by 100. And that gives us 233.333 blah 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 percent. And this 100 technically is 100% that we're timesing it by. So it says it wants it to the nearest percent, so that would be 233%. Rate is always something over time. So in this question, we can work out the rate as being the pay, or the final pay, or whatever, over time. Now we're asked what the time is, so we're just going to put the time on the left hand side, and we're just going to swap the rate and time over, so it would just be pay over rate. The pay is £180. The rate is £12 an hour. So it'd be 180 divided by 12, which is 15. So it'll take 15 hours. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimeters high. And how wide will it be? Well, it will be 2 centimeters wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimeters wide and 1, 2, 3, 4, 5, 6 centimeters tall. There we go. And make sure that you don't add any three-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly two-dimensional. So we can quickly draw a line of best fit for here. And it looks something like that. And if our line of best fit is increasing, like we have here, then we say the data is positive. If, however, the line of best fit is decreasing and looks like this, we say that it's a negative correlation. So positive if it's going up, which this one is, so it's a positive correlation. And if it's going down, then it's a negative correlation. If the data is all over the place, so it looks like something like this, where you've got the points everywhere, we say that's no correlation. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100. Which give us 1.015, and then finally what we do is we get the 17,000 times it by the multiplier, and when we do that we get 255. So Lenny has 255, Jane has 240, so it says which of the employers has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. So we're asked to reflect this shape across line x equals 0. So we've got to first of all work out where the line x equals 0 is. The line x equals 0 is going to be the y-axis because it's where anywhere along that line x coordinate is going to be 0. And so to find out where our new shape will be, you pick a point on our triangle and you count how many jumps to get to that line. So 1, 2, 3, 4, 5, and then we count another 5. 1, 2, 3, 4, 5. So one of our coordinates is going to be here. Do the same thing again and pick the one to the right. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we've got a coordinate here, and finally we've got this coordinate here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And as you get good at it, you don't necessarily need to do all three. You might only need to do one, and you can figure out the rest of them from that. And let's just make sure this is nice and straight. And it says to label our triangle B. So the pass mark for the test is here, and we can see that there are 2 students who passed the test. So it's 2 students out of 2, 3, 4, 5, 6, 7 in total. And we want this as a percentage, so we're going to times it by 100%. So we do 2 over 7 times 100, and that gives us 28.571, blah, blah, blah. And it says it wants it to the nearest percent, so that will be 29%. Here we're given angles on a parallel line, and the first thing I do is just find out what letter they connect with. And if you look, this is kind of like an upside down F, so they're F angles, and F angles are always equal, so X is going to be 11 degrees, that's the easy bit. Difficult bit is figuring out Y, and the way I remember it is that cor F bonding, and I just put the F in there, so it's going to be cor F bonding is what's in my head, but what I write down is obviously cor S bonding angles. But it's just a way that I have to remember it. One thing we need to know about a parallelogram is that the lengths that are opposite are equal. So this length here is going to be 5 centimeters, and the length at the bottom is going to be 10 centimeters. And to work out the perimeter, all we need to do is add up the length. So what I do is I pick a point and I go around the shape. So we're going to go around the shape. So we're going to do 10 plus 5 plus 10 plus 5, and then when I return to the point where I started, I then stop. And when you do that, you get the answer of 30. And it's a perimeter, it's a distance, so it's centimeters. Some people often forget and put centimeters squared. You only do that when you've got an area. So with a perimeter, it's a length, it's a distance, so it's just 30 centimeters. There are a number of different ways of working out this question. You can find out the amount of tissues per penny. You can work out the amount of, or the price of one tissue, or you can get all the amount of tissues into the same amount. I'm going to find out the price per one tissue. And we're going to start off with the 24. And what I'm going to do is I'm going to convert the money into pence, just to mean that we don't have as much decimal. And we're going to do 807. I'm going to divide by the 24 to find out the price of one tissue. So that is 33.625. And so I'm just going to round that to 33.63. I'm just going to round everything to 2 decimal places, which says in the question. Next one, we're going to do the 20 soft tissues. So this time I'm going to do 683 divided by 20. When I put that into the calculator, you get 34.15, so that's already 2 decimal places. And then finally we're going to do the 15 soft tissues. So we're going to do the 623 divided by 15 to find the price per tissue. It should be 41.533 blah blah blah, and rounded would be 41.53. So if you buy 15 tissues, it will cost 41 pence. 20 tissues, it will be 34 pence per tissue, but 24 tissues will be 33.63. So that's by far the cheapest. The best value is the 24 tissues box. Now, there's such thing as buying in bulk. Generally, the more you buy of something, the cheaper it is. Don't rely on that. Both in the GCSE, both in the exam, and in real life. Sometimes in real life, if you buy more of an item, actually per tissue, sometimes it becomes more expensive, especially if there's a special offer on the smaller box. The formula for the area of a trapezium is half A plus B times H. Now, A and B are the lengths of the bases of the trapezium. Now, it's easy to find the bases because they are the ones that are parallel. It doesn't actually matter which way round we label these, so I'm always going to put A on the left and B on the right, or I always put A on the top and B at the bottom, but it doesn't matter which way around you put them. The height, which is represented by H, always hits the bases, A and B, at 90 degrees. You can see that this length here does not hit the bases at 90 degrees. This is an acute angle, this is an obtuse angle. So that is not the height. The height is going to be this one here, because it hits both of the bases, A and B, at 90 degrees. So let's put these values into our formula. So half times 5.4 plus 7.6 times 2.3. So that's going to be half of 13 times 2.3. And that's going to be 6.5 times 2.3. Then that will be 14.95. All the units are in centimetres, therefore the unit of the area will be in centimetres squared. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the centre, that's a diameter. If you've got a line just going to the centre, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers, so that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got X on both sides, so we look at the X's. We've got 12X and 6X, so we always take away the smaller amount. So we're going to take away the 6X both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got X is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for X? Now, it is tempting to write down 10, but it says X has to be less than 10. So the biggest number we can get that is less than 10 is 9. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by -3, because they're minusing 3 each time. So we know that the number before the n is going to be -3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3 and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the -3n. So it's going to be add 20. So our answer is -3n plus 20. To work out the maths, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082. And that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimeters cubed. Times that by the 5082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit, because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. Factorising is the opposite of expanding, so instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x, and we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want, but I'll use Smiles and Rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. So the first thing to do with these questions is figure out what information we have. So the question says that we are accelerating a toy car at 6 meters per second squared. So the acceleration is going to be 6 meters per second squared. And it says it's going to be for 14 meters. Now, that sounds like a distance, but in the context of these questions, because we're talking in vector terms, it's called displacement. And weirdly, we use the letter S to show displacement. So the displacement is going to be 14 meters. Now it looks like we don't have any more, but actually it says from rest. So the initial velocity therefore would be 0, because from rest means it wasn't moving at all at the start. We're looking for the final velocity, so we're looking for v. So let's have a look at which formula we're going to use. So it's not going to be the top one because we're not given time. It's not going to be the second one because we're not given time. So it's going to be that third one. So we've got v squared equals u squared plus 2as. So we're looking for v, so I'm just going to leave that v squared there. U squared, well, that's just going to be 0 squared, plus 2 times the a, which is 6, times the s, which is 14. And when you do that, you get 168. And we've got v squared equals, so we need to do a bit of solving here. We need to do the inverse of square, which is square root. So we're just going to square root both sides to get what v equals. So square root of 168 is 12.961, etc. And we're going to round to 2 decimal places, which will be 12.96. When translating, we translate with vectors, and the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape from there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the 2 parallel sides here, which I'll just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times a, which is 28, plus b, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore the radius would be half of that, which is 7. And the area of the circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. So if 2 people liked action but not comedy films, and in total 11 liked action films, Therefore, there's going to be 9 who also liked comedy, because these two have to add up to 11. Now, if there's 9 who liked action and comedy, and 16 who liked comedy in total, if we do 16 take away the 9, that leaves 7. So 7 only liked comedy. It says there's 23 people altogether, so what we're going to do is take away the people who liked action, the people who liked both, and the people who liked comedy. Take all those away from 23, and we're left with 5. So the answers are going to be 9, 7, and 5. Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7, and 8. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. To find average speed, we do the total distance and we divide it by the total time. Now, in this question, we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. So we're going to first of all work out the curved surface area, which is just this bit here, not including the top and bottom. And the formula for that is 2 pi r h. And the h is this bit here, so it's 2 times pi times the radius at the top, which is 12, times the height, which is 19. And that gives us 1432.566, blah, blah, blah. Next we go work out the area of the circle at the top. So circle area. And the formula for that is just pi r squared. So pi times 12 squared, which will give us 452.389, blah, blah, blah. Now there are actually 2 circles, so when we work out the total surface area, so total surface area, we add the curved surface area to 2 lots of the circle surface area, or areas of the circle, because there's 1 circle at the top and 1 at the bottom. and that gives us 2337.344 blah blah blah, and 2 decimal places, that is 2337.34. The important thing when choosing a sample is that everyone has an equal chance of being picked. So if you look at method 1, picking the first 30 students who enter the school is going to have a bias, because there might be a difference in the type of person who arrives early to school to the type of person who might arrive later. If we select a class in the school, then they're generally all going to be the same age. So if it's a year 7 class or a year 11 class, they're all going to be the same age. It might seem that it's fair that picking the first 30 students alphabetically, so A to F or whatever, again, that's not fair, because the people at the end of the register don't have an equal chance of being picked. So you need to make sure everyone in your population has an equal chance of being picked. So picking 30 students out of a hat containing all the students' names in is definitely the fairest way of picking a sample from this list. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. When something is cubed, you times it by itself 3 times. So we're going to do the same here. So we've got 5x to the power of minus 6 times 5x to the power of minus 6 times 5x to the power of 6. We're going to put the 5's together. So 5 times 5 times 5. And the x to the power of minus 6's together. Five times 5 times 5 is 125. Now when you times powers with the same base, which we have here because they're all x to the power of minus 6, you add the powers together. So minus 6 plus minus 6 plus minus 6, which is going to be minus 18. Something else we could have done is we could have done 5 to the power of the 3 here, 125, and then done minus 6 times the 3, which would have given us minus 18. So this pyramid's made up of 2 different shapes. We've got the square at the bottom and we've got the triangles on the sides, and there's 4 triangles, but they're the same shape. And we know that because the pyramid's equidistant to all corners of the base, which basically means that the triangles are going to be equal. So we're going to work out the square first. I'm just going to label it with an A. And so the square is going to be 15 times 15, which is 225. Next we're going to work out the triangle, which I'm just going to label as B. And triangle is half times base, which is 15, times the perpendicular height, which, because this is perpendicular, is going to be that 12. And so that's going to be 90. So to work out the surface area, we're going to do the 225 plus 4 lots of the 90, because there's 4 triangles there. So that's going to be 585 centimeters squared. So I'm going to write this out again just to give us a bit more space. And the way we're going to solve this is exactly the same as if we had an equation there, well, with an equal sign, obviously. But with this one, if you times or divide by a negative, you've got to flip the sign. We're not going to be doing that in this one, but that would be one of the differences. So we're going to take away 10 both sides to get 7x on the left-hand side. Make sure you don't put an equal sign in there, otherwise that is instantly 0 marks. Then we're going to divide by 7 both sides to get x on its own. So it's x is greater than or equal to 11 would be the answer. So we're going to start off with x equals 0, and we're going to write out this equation but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2. So it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus. So it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, which should be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around. And we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.69. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So the first thing I ask myself is, what has happened to this shape? Well, it's actually changed size. So we are looking at an enlargement. And the next thing I need is the scale factor. So the scale factor is, well, let's have a look at the squares at the bottom. So we've got 1, 2, 3, 4, and it's changed to 2. So 4 times what is 2? Well, that's going to be a half. So it's actually halved. And last thing I need is the center of enlargement. And those are coordinates. Now to find those coordinates, we join up our two triangles. Let's try and get a good, there we go. And we just join up like for like points. So I'm going to join up the two tops, and I'm going to join up the two right angle parts, and I'm going to join up the bottom right part as well. And you notice that they all cross at this coordinate here, and that's actually our center enlargement, so that's going to be 8 minus 7. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sports circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3X equals, and then 66. We're going to divide that 3 both sides. So we've got X equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of X minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2X minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. So we're asked to find the vector 3a plus 2b. So we're going to start off by working out 3a. And so we're just going to times the top and bottom of a by 3. So that'd be 9 and 6. And to find 2b, we do exactly the same to the second one, but we're going to times it by 2. That'd be minus 2 and minus 4. And so to find 3a plus 2b, we're just going to add the tops together. So 9 plus minus 2. And add the bottoms together. So 6 plus minus 4. 9 plus minus 2 is 9 take away 2, which is 7. And 9 plus minus 4 is going to be 2. So the vector is going to be 7 and 2. So this question is asking us to find the probability of not A and B. So if we look at and I'm just going to quickly draw out a similar Venn diagram. So if this is A and this is B, then not A will be everywhere apart from A. So it will be all of this here. And if we do the same thing again, and this time we're interested in where B is, so we've got A and B, then B is this part here. So if you have a look and see which are shaded in both, you can see that this part here is shaded in both. So this part here is not in A and is in B. So it's this 3 here. So the probability is going to be that 3 over the total amount. So all of these added together, which is 25. So we're told these triangles are similar, which means there's a scale factor between them. So we've got 2 corresponding lengths here and here. So we've got to work out what we times the 22 by to get to the 99. So we do 99 divided by 22, and that's 4.5. So we know we times this by 4.5. And so we do the same with the 35. So we times that by 4.5, because that's our scale factor. And 35 times 4.5 is 157.5. Whenever we draw a curve, which here we have a reciprocal here, we need to draw lots and lots of coordinates, and then we join them up with a nice smooth curved line. So we're going to do, basically we're going to go up in halves. and 3. Right. So we're going to start with -2, and we're going to type that into the calculator using this formula here. So we've got 1 divided by brackets -2 plus 8. When you type that in, you get 7.5. Could do the same thing with -1.5, and you get the answer of 7.3 recurring. Same thing with -1, you get 7, and -0.5, you get 6. Now, when you put 0 in, whenever you have 0 at the bottom of a fraction, you'll just get a maths error. It's basically you can't divide by 0. So that does not exist. That's a positive infinity, negative infinity, or undefined, as mathematicians will call it. It's not technically infinity, it's a long story, but it just can't exist. So let's keep going. So we've got 10 for that, then 1 is 9, then 8.6 recurring, then 2 is 8.5, then 8.4, and then this would be 8.3 recurring, blah, blah, blah. Okay, now we start plotting this, and this is not going to be easy because the scale is going up in 2s. So 7.5 would be about 3/4 of the way up here. Then we've got 7.3, which would be slightly lower. Then we've got 7, which would be slightly lower. Then we've got 6, which would be a lot lower. Okay, then we've got at 0.5, we've got 10, then 9, should be, yeah, be about there, then 8.6, 8.5, 8.4, it's very difficult to do it from these ones, 8.3, okay. Now, this 0 here, it kind of tends towards infinity, both positive and negative. On one side it goes towards the positive infinity, on the other side it goes towards the negative infinity. So what is helpful to do when you're drawing this line is to turn your page sideways. And I'm going to try my best here. I can't actually turn this sideways, so we're going to try our best to connect these up. And I've got kind of a weird hand angle going on. So this is going to go towards negative infinity. This side, you can see it's going down there. And you can see this side here, on the right hand side, is going towards positive infinity. So, like that. Now there's no, there's a lot of leniency. You can see that I've probably gone too far to the left there. And so really what it should be is a little bit less dramatic, maybe, more dramatic, I don't know. So I think I've done exactly the same thing. But all of what I've drawn will give you the marks. They are very, very lenient when it comes to this. The big things with this is that this line here can't go to the left of the y-axis for this question, and this line here can't go to the right of the y-axis. Essentially, the y-axis, where x is 0, this line here, the left-hand line will never cross the line and the right-hand line will never cross that line. That's where it flips between being negative infinity to positive infinity, kind of, it's a way of visualizing it. And you can see here, the more points you've got, the better. And with reciprocals, really what we want is the points to be between 0.5 and negative 0.5. For this question. So we could do probably another coordinate at a quarter and minus a quarter would help us. And yeah, that's how you plot a reciprocal. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. Acceleration is change in velocity over change in time. So change in velocity where it starts at 0 and goes up to 150. So that would be 150 over the change in times. Well, the time starts at 0 and goes up to 5, so that's 5. And so 150 divided by 5 is 30. The velocity is in meters per second, the time's in seconds, so the units will be meters per second squared. So it's 30 meters per second squared. So in this question we've got a right angle triangle and it involves two lengths and an angle, so it's going to be a trigonometry question. So we're going to start by labelling the sides. So we've got the hypotenuse opposite the right angle, opposite is opposite the marked angle, and the adjacent is between the right angle and the marked angle. Now notice the opposite doesn't have a number or a letter next to it, so we're going to cross that out, we're not interested in that. And we're next going to draw our triangles for SOHCAHTOA. So it'd be SOHCAHTOA. And we cross out the opposite, so we're not looking at a sine or tan, we're going to be looking at the cos. So it would be cos the angle, or cos x, equals A over h. And the angle is 37, so cos 37 equals 7.1 over x. Now, whenever you're in this situation, and we're just going to put our solving lines in because we're going to be solving this next, if I can press the right button, there we go. And whenever you're in this situation, what you can do is swap the left-hand side, it has to be the whole of the left-hand side, with the x at the bottom. You can just swap those over. And effectively what we're doing is multiplying both sides by x, and then dividing both sides by cos 37. So when we swap those over, we get x equals 7.1 over cos 37. When you type that into your calculator, just make sure you close the bracket. If when you type in cos it opens a bracket, make sure you close the bracket before you ask your calculator for the answer, or press the equals button, and that would be 8.890 blah blah blah. And when you round that to 2 decimal places, it will be 8.89. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.